Welcome to monochemistry, and we're going to look at a little bit about balancing, and these are slightly harder hydrocarbon equations. Now, a hydrocarbon is quite simply a molecule like this that has carbons and hydrogens. Okay, and you see these quite a bit. It's a combustion reaction, okay, because you've got hydrocarbon plus oxygen. Okay, so we're gonna balance this. The only reason it's a little bit harder is because there's one thing that doesn't quite balance out as nicely as in previous ones that we've looked at. So we're gonna look at this one tonight. So remember the rules for balancing. The first rule is you balance your metals. Now, if you look across this one, there are no metals, so that's easy. So what we're gonna do now is we're gonna skip right to the carbons because, as you know, we leave the hydrogens and the oxygens always till the end. Notice here we've got 8 carbons. So what I'm going to do is I'm going to go ahead and I'm going to fill in an 8 here. Because on this side, on the product side, see the arrows over here, on the product side, I've got only 1 carbon. So 8 carbon dioxides would give me 8 carbons, which is what I want. Okay, hydrogens come next. Over here, I've got 18, and over here, I've only got 2. So blank times 2 equals 18, or 18 divided by 2, equals 9. Now here's the problem. If you look, I've now got 8 times 2, which is 16 oxygens, and I've got 9 more here, for a total of 25 O's. Now look here. I've got O2. Well, what whole number can I multiply O2 by to get 25? And the answer is none. There is no such thing as a whole number that I can use to fit in there. So what do I do? Well, when whole numbers don't work, we have to use decimals. Not so bad, right? So what you do is, you know you have 25 oxygens over on the product side, and you know you have 2 oxygens on the reactant side. So you say blank times 2 equals 25. Well, what times 2 does equal 25? Is that 12 and a half? 12.5. Okay, but here's the thing. 12.5 isn't a way to leave it balanced. You can't leave a decimal. Okay, so here's the trick. The trick is to take every single number and multiply it by 2. The reason we're multiplying it by 2, by the way, is because we had a 12.5. So 12.5 was our imaginary, gotta get a color on here. 12.5 was our number here. Get a slightly thinner thing here. We had 8 here, and we had 9 here. Agreed? Okay, so we can't leave it like that. We've got to multiply this number by 2. Now think about it. 0.5 times 2 is going to give you a whole number every time. Right? So depending on what this number is, you're going to pick some whole number to multiply it by that will give you a whole number. So if it was 0.25, you'd multiply it by 4. If it was 0.333, you'd multiply it by 3, etc. Okay, so you're always looking to get it to be a whole number. But this one, pretty straightforward. We just got to multiply it by 2. So that's what we're going to do. We're going to take everything in here. This was a 1. So 1 times 2 is a 2. This is a 12.5, so that's going to become a 25. 18 times 2 is a 16. And 9 times 2 is an 18. So there, 2, 25, 16, 18 is my balanced chemical equation. No worries. All set and done. Here's a little hint for you. Anytime you get an odd number of oxygens on your product side, anytime you have to use an odd number here to begin with, you're going to have to do this. Take that hint. Okay, anytime you're going to have that, like an odd number, 7, 5, 9, 11, whatever, on this side right here, you're going to have to do this process. If it's an even number in this box here, then you're good. You don't have to worry about it. But odd numbers, you're going to have to do this. And that, in a nutshell, is how you balance the slightly harder hydrocarbon equations. Take care.